Hello, and welcome to today's webinar, Freedom to Evolve, Flex-Grid ROADM Strategies for Multi-Vendor Growth. I'm your host, as usual, Sean Buckley, Editor-in-Chief of Lightwave. In today's webinar, we'll explore how adopting open ROADM strategies combines cost efficiency with long-term adaptability, creating transport networks that are ready for both today's demands and tomorrow's unknowns. Today's webinar, which is the third in a series we have done with PacketLight, is brought to you today by PacketLight. We thank them for their support with these webinars. Just to let everybody know, a white paper and digital brochure is also available for download as well. I'd like to introduce today's speaker, Michal Naor, Vice President of Development for PacketLight. But before I hand off things to her, let me quickly review our webcast setup for those of you who may be joining us for the first time or for the first time in a long time. I'll start with the Ask a Question box you see near the slide area. I invite you to feel free to use this to ask questions at any time during the event today. To submit a question, just click on that box, type in your question, and hit the send button. We'll address your questions after she has finished her presentation. Now, in the event that you run into a technical problem during the presentation, you can call for help via the Q&A tool. Just describe the problem, hit the question and submission button, and Milan, who's today's webcast technician, will be happy to help you out. Next, if you know someone who might benefit from seeing this webcast, you just want to revisit the presentation yourself, the event will be available on demand from our webcast archive for the next several months. We'll send you an email with the link to the archive sometime in the next day or so you should feel free to forward to your coworkers and others. And the archive version of the webcast will also be accessible from our webcast archive section of our website, which you can reach via our homepage at www.lightwaveonline.com. And if you want to get a copy of the slides, you can reach out to PacketLight directly and do that. And with that, let's begin our look at Flex-Grid ROADM strategies for multi-vendor growth. Michal, the floor is yours.
Hi, everyone. Thank you for joining. I assume that half of the audience here are partners and friends and customers that are working with us for many years. And the rest of you guys, the newcomers, thank you for joining us, and we hope that you will join our family soon. With me is also here Yochai. He's our technical director, partner, friend, and for many, many years, we are working together. So he's your expert. Please ask any questions and let's see if he can answer them. We are going to talk today about the amazing technology of ROADMs. So we try to build an agenda that will provide a good overview of this technology that is called ROADM, and it will scratch your curiosity for further information. We recognize that it's impossible today to predict exactly how this market will grow and where are we heading in the next few years, but we'll try to do it as well. The growth of backbone, the growth of AI and other factors are driving this market to triple and to quarter the amazing information. So for now, what we did for you is to put an agenda that I think that will cover both some technical information and some applications. So it will give you a good overview of this market and where we are heading. So the first one that we wanted to, the first aspect that we wanted to discuss, this one, okay. So the first aspect that we wanted to discuss are the market trends. So what's driving this market? We looked at the variety of market researches. And as you can see from Market Research Future that we decided to take, they have nice slides. So we decided to use them. This market is going to triple itself in the next 10 years. So what's driving this market for this crazy growing? So first, the OTN and the transport OTN market is going to double itself. The data center interconnectivity is going to triple itself. AI, cloud, DCI, everything is driving this market more and more to grow. Migration to 400 gig and 800 gig also drives us to all kinds of requirements that were not available till now. Expansion from what was before only long haul ROADMs were usually installed in long haul core backbones, now are going also to metro, and we will see it in the next slide. And of course, the maturity and of the technology and the lowering of the cost of this technology is making it more and more available for others to use. If we look on the different markets, geographical markets here, so the US market was the first to drive this technology. There was the need, and there were the manufacturers, so it's a win-win. So obviously this is the biggest market in the world and still driving the ROADM technologies. The next ones that were early adopters were the Europeans, both the Germans and the UK. The Germans with broadband installations, and the UK Ofcom that opened the market in the early 200s and actually opened the market, and by that everyone was looking for how to be the first adopters of this technology of ROADMs. One of the fastest growing of the ROADM market is obviously Asia Pacific, especially with the emerging growing countries, China and India. And this is the fastest growing market that we see in the next few years. Regarding Latin America, well, the opinions differ due to the reason that the need is there. They need to digitalize, they need to grow. It's a huge area. And again, putting LATAM as one big region and not discussing each country particularly, but in general, a lot of politics and a lot of processes and that are happening in these countries might slow down the process of using the ROADMs. But what's nice about it, this is what we discussed before, more and more different type of market segments are using the ROADMs. If previously only core networks by very big carriers, like tier 1 carriers, were using the ROADMs, more and more metro and enterprises are using this the ROADM technology. And as you can see here, a variety of, again, we took it and you can see here a variety of market segments, and we can tell you from our type of customers that we have hospitals and research institutes and broadcasters and utilities. So really, anyone that has either a huge number of services or wavelengths, but not a very big network, is moving more and more today to use the ROADMs. Next, so what is a ROADM? What is a ROADM? Well, that's a very simple one to see. It's really what is written here. It's a fundamental element, network element that is based on some hardware and some software. The hardware is a WSS and OCM, some amplifiers, and the most important part is the network management system, which we will discuss further in our next slides. And but that's just that you will understand what is a ROADM. So it's a fundamental network element that allows us to add and drop services along the ring, everything automatically configured by a software. We put here this timeline to show you how young is this technology. Because, we are working in this market. PacketLight is 21 years old already, and we are working in this market. And when you look at this timeline, you understand that actually the initial really GA'd colorless directionless ROADMs came around 2015. So less than 10 years ago, and they were adopted by the big carriers, tier one carriers. So now you can even understand better the maturity of this technology and why it is adopted so quickly by everyone, especially when the prices are dropping of the components and everything. So that was important for us to show you how actually young is this technology and where we are heading. So a little bit explanation. Sorry, I'm used to click here, but I need to click over here. A little bit about the differences of what is a fixed grid ROADM, a flex grid ROADM, and an open and flex grid ROADM. So at the beginning, we had a fixed grid ROADM. The customer needed to choose between a 100 gig spacing or 50 gigahertz spacing, and that's it. His network is fixed to either or, and on those, he could run services up to 96 or 98 wavelengths of 50 gigahertz spacing. With the arrival of the 400 gig and 800 gig, suddenly there is a problem, and the fixed grid is not enough. We need something that will allow us to grow to the capacity of 400 gig and 800 gig by adding more flexibility to the ROADM. We will discuss exactly how we do it later on. But then we got the flex grid ROADM coming, which allows us to choose a variety of spacing for each one of the different wavelengths. And then came the requirement for open. And open for all means that it's a non-vendor locked system. We are looking for a system that will be open for any third party. The customer owns his own network. He is the owner. He doesn't need to pay anyone. He doesn't need to ask anyone for licenses. And this is very important to remember. An open and flex ROADM provide you the capability to grow, to scale, and to have a flexible network that will serve you for today and in the future beyond what we call, and you will see the beyond even later. So this is the way we in PacketLight, well, it's the technical architecture of one direction of a PacketLight PacketLight ROADM. Okay, so this one direction integrates inside two WSSs in and out, the OCM, some amplifiers. Yes, you can see all the other elements here, but in general, it's all integrated in a 1U, very powerful, power efficient 1U integrated solution. So that's in terms of the hardware. And the next one is the most important thing, is the network management system. This is our system that allows you to add and drop services or wavelengths. I don't like to talk about services since in each one of the wavelengths we can have many services aggregated, but we will discuss it later on. So add and drop, A to Z provisioning, to discover topology, automatic power balancing, SLRH, that means that you get alerts of overpathing laps. The NMS allows you to create a service, a path in 6 simple steps. And this is where you don't need an expert team, and you don't need to train for hours. Really, in a very simple system, you can run this with a very small team. You can run our system. We have a customer that says that this is what he likes about the system, that it's easy for them to manage with a relatively very small team of network managers. So when we are talking about a passive solution is based on muxes, and actually when we have a service running over the network, and a service when a wavelength is coming from a long way, along the pass-throughs, it's getting weaker and weaker, and the other services that are coming from different sites are stronger. Then we need to send a team physically to each one of the sites, either to pass through or to with attenuators to power balance each one of the services. And every time that you add a service, you need to power all the wavelengths again. You need to document everything. And if you work like myself, that everything, is written in hieroglyphics. So you need someone that really will keep a very good Excel about which service, which wavelengths is going where. However, if you have a small network with relatively a low number of wavelengths and not changeable, you definitely can work with a passive network. At least, at the beginning, you can always grow to a ROADM network in the future. So it's perfectly fine to stay with the passive, but the nice thing about the ROADM network, that it's everything done automatically. No patching, no documentation, no need to power balance. You sit in your office and everything is done automatically, and we will discuss it in a second as well. So a quick summary of what we did till now. So what we discussed till now, just a small review. So we discussed about the history, the timeline of this technology. We discussed about the market trends. We discussed about a passive network and a ROADM network. And the most important, that we are looking for a network that allows us to scale, to be flexible, to scale, and to be open, and to grow to the future needs that are unpredictable today, with all the changes that are coming through us due to many market requirements, from AI to data center interconnectivity, gaming, videos, whatever. So that's a quick okay, so that was a quick summary of this, of what we did till now. So what are the benefits of using a ROADM, which we already began discussing, but we will go over it again and again because it's important. In a ROADM network, you don't need, first, as I said, what I like about it, you don't need to document anything. Everything is documented for you automatically. You have a power balancing, no need to manual patch, no need to send teams, minimize time of downtime. You can add sites very simply. Everything is already configured. So to add even a new site is relatively simple to a ROADM network. And as I said before, what is important in this is the network management system. It allows you to assign new services with or without protection. It shows you all the paths that are available for you. It shows you, it can send alarm to different groups. It can show, it saves, of course, all the history of what the events and alarms that are in the system. You can have automatic upgrades. Nothing that I'm saying here about our NMS is, inventing a new system. Every NMS does it, but it's so nice to sit in your office and do all of this instead of course, going site by site and the need to manpower everything. So when we are talking about the another thing that the Flex-Grid allows us, and we will discuss what is the Flex-Grid in a second, it allows us to enable a more efficient use of the spectrum and dynamically allocate the spectrum, and we will discuss how we do it in a few slides. A mix of and the mix of different capacities on the same spectrum, which we know is limited. So we will discuss it in the next slides. Before that, I wanted to say that you will hear a lot when we will begin looking for your next ROADM backbone. You will hear all the time the term of CDC-F. So CDC-F stands for colorless, directionless, contentionless, flex. Flex, by the way, is relatively new in this. So that's the newest addition to the CDC. And we are going to discuss a little bit what is CDC. So everyone will know what a CDC is and will be able to allocate it. So though CDC begins with a colorless, directionless, contentionless, we will begin with explaining what directionless means. So directionless means that we can take any wavelength that can be sent for any, or received, of course, to any direction on each, with east or west. East or west. Yeah, that's better. So if we look at this lambda over here, wavelengths, we can drop it in any one of the sites. What you see in front of you is it's a four sites row. It's a site with four directions, and we will discuss about it in a second. But first, we are going over these different terms. So directionless, we can send the lambda to every site. Again, we are talking about lambda, wavelengths, color. These are the same terms for the same wavelengths the term. We are not talking about a service, because in each lambda we can aggregate a variety of services with the Muxpander, for example. But this is for a different webinar, talking about Muxpanders and the transponders. Talking about colorless, the colorless is taking any, since we are using today tunable optics, so they are all fully tunable, and the ROADM is fully flexed, so there is no need to adjust an optics to a port in the ROADM. They are all open, so you have colorless and directionless already together. So every wavelength can go to any direction. So we covered already colorless and directionless. Now, regarding contentionless, this takes me a little bit explanation that I hope that I'll do it again and that I'll do it correctly. But if not, Nathaniel will tell me tomorrow. So If you look at this diagram over here, we have a device that actually has the same. Okay, we have a device here with different services. One has a 400 gig service, the other one has two 100, the third one has just 100. But all these lambdas, all these wavelengths are the same wavelengths. So for example, they are all 22 wavelengths. So each one carry different services, but they are the same wavelengths. And we can drop each one of these lambdas to different directions without any contention. So this is the contentionless. So we are already with the colorless, directionless, and contentionless. The last thing that we need to cover is the flex. So we discussed that services till a few years ago were only 100 gig, 200 gig, and 10 gigs. And suddenly we have the 400 gig, the 800 gig, and beyond. And suddenly the 50 gigahertz spacing and 100 gigahertz spacing are not enough for us. Why? Because if you take a look at this one, in a 50 gigahertz spacing, we can put 100 gig services and 200 gig services. We can actually have maximum of 98 wavelengths of 100 gig or 200 gig wavelengths. But what happened when we went to 100 gig, to 800 gig? With 800 gig, the 800 gig requires 150 gigahertz spacing. And then it just doesn't fit in 50 gigahertz spacing. We needed to do something else. We needed to provide a flex grid, something that will allow us to maximize the spectrum to different capacities. So actually, our flex grid is from 50 gigahertz in increments of 12.5 gigahertz, and today reaching 150, and for the 1.6 we will need, I think, 300 already gigahertz spacing. So this is the way to win the maximum capacity on a flex grid. And if we are looking at another view of the same, using the flex grid in a different way. So actually, if we are using a flex grid for a 50 gigahertz spacing, it's very nice when we're using for 100 gigs or for 200 gigs. But when we are going for 800 gigs, we would need a fixed spacing of 150 gigahertz spacing that is only 32 wavelengths. And by that, if we are using on the same network 800 gigs and 100 gigs, we will waste a lot of the spectrum. By using a flex grid, we can practically provide the right capacity for each one of the required wavelengths. By that, we finished already colorless, directionless, and flex grid, contentionless and flex. So the challenge of implementing flex grid is that many of the networks are existing networks. So first, if any of you that are listening to us now has a backbone of PacketLight ROADMs, call us to see if you can upgrade to a flex. Most of the guys that have our ROADMs can upgrade to flex, so contact us, okay? So that would be easy for you guys that has already a PacketLight ROADM. To adapt the ROADM technologies, so that's the first thing. To adapt ROADM and to go from fixed from a fixed network to a ROADM, and support different spectrum slides. to redesign networks through the NMS or redesign a full network. We need the Flex-Grid with tunables and to implement protection paths, actually to redesign a full network. So that's the challenges. Sorry. I promised you to take a deeper look on what does it mean a four-direction network. So I need you in a few minutes, just a few minutes more, to concentrate of this, what we are showing you. So we built here a network. And you can see here two backbones, the green one, backbone 2, and the blue one, the backbone 1. We are concentrating on site E here in the middle. Each one of the sites you can see has a few directions. So in the corners, we have 2 directions, okay? Here in the middle, we have also 2 directions. Here we have 4 directions, and here we have also 4 directions. So we enlarged this site over here that you can see you can see the ROADMs, you can see the entrance of the device. It doesn't matter if it's a muxponder or a transponder. So as I said, a muxponder can carry 20 times 10 gigs, okay, on the same lambda, on the same wavelengths. And as you can see, each one of these ROADMs are connected between themselves in a meshed network that allows us this connectivity between them, and of course the amplifiers if needed over here as well. So this was an example of how a 4-degree ROADM sites look like. We put here an example, and I'm happy to tell you that we are almost at the end. So we put here an example of one of our customers' ROADMs. You can see here some sites of 4 sites ROADM and 2 sites ROADM, 2 directions and 3 directions. And the sites with our transponders and muxponders. But what's nice about it, that it's his own backbone. He has a variety of third-party running on top of it, which we don't know. He doesn't call us. Well, he calls us when he has a problem. He calls Yochai usually. So it can have, and usually what we see that they are adding, especially switches with colored optics, especially for the short distance connectivity between short sites, distance sites. So in a big summary, again, we are trying to show that the scalability, the changes in requirements requires also a flexible network with a scalability, and especially an open one that allows the customer to own his own backbone and not to call and not to pay for additional licenses or anything like this. Actually, this concludes my side before you shoot all the questions to Yochai. But I wanted to say first, you can scan this QR and you will get all my details immediately, and then we can WhatsApp or email or whatever you want. And I wanted to quote a very important character in my life, which says, to infinity and beyond. Well, if you know Buzz Lightyears, we change it to 800 gig and beyond. So just remember that it's a very important quote in my life, and usually. So Sean,
Okay.
I'll shut up now.
No, that was great. Thank you very much. I'll also mix in some of my own questions that I kind of have about your theme there, but I'll take a few from the audience here. What advancements do you expect to see in WSS technology products to keep up with future network demands? And how do you see WSS play a role in multi-rail networks? Those are two questions, I guess, but want to take that?
Okay, for the first one, it's very simple. As once you build such a Flex-Grid network, you can build almost whatever you want in order to get any new service or any new technology of light through your network. So this is simple. The second one, can you repeat, please, Sean?
Sure. The second one is, how do you see WSS play a role in multi-rail networks?
I am not sure what is multi-rail, okay? But
Okay.
this is maybe it's different terminology than I know. So
Yeah, maybe we
if
need to.
the
Yeah,
audience that wrote it can give some explanation of what he is looking for, it will be helpful for us to answer maybe after.
Okay. Yeah, well, maybe after the webinar, we can he can follow up. Yeah. Okay. So here's another one here. It's kind of a statement and a question. I have been looking at very long hops for some time, 40 minus under 40 dB attenuation. What would be your comment on the ability of amplifiers, EDFA amplifiers in general, and those from PacketLight in particular, to transmit well above 25 dBm? That's the first part of the question. Yeah.
Okay, so in general, the limitation once you use WSS is about 28 dB between hops. Okay, this is just a finger rule, but if you will need more than that, there is no limitation to add Raman in front of after the WSS in order to have it for long reach. So if this specific question referring to some real application, we will be very happy to help with it and get information and try to get the right design for this.
Okay. Kind of a general question. I'm kind of taking it from the audience and just from me. I assume that you guys are also probably seeing demand for these things with traditional networks, but also probably from data center providers as well. I mean, we could maybe address that a little bit. Yeah.
Sure. So there are many application of data center where you can use WSS. For example, if you have your main campus and multiple data center that you would like to build a ring between, and you want to take services or waves from your main campus to those and also protect them. This is very a known use case for DCI application with WSS.
Okay. So let me just ask, I mean, you guys gave a really great presentation on kind of the whole open ROADM concept. I mean, where are we at with that? I mean, I assume that, you did kind of cite a customer, but just in general, I mean, where are we in the adoption phase of that those kinds of platforms? There's a lot of, it seems like there's a lot of benefits, flexibility, like Michal talked about, and probably lots of other things to enable. But just what is PacketLight seeing in terms of adoption, and how is that the market moving, adopting? Yeah.
Well, we see that more and more more and more customers are requiring ROADMs, even for small networks, as we said, hospital campuses, and not the traditional customers, and we see it more and more also in our terms of growth of sales with the ROADMs since the past few years. So that would be, it's almost coming in every requirement, of course, in every tender, even it's a small tender for just a 3 sites. So you see it coming all the time.
So it'd be like you said, like a hospital or some kind of a government agency, people that maybe manage their own
definitely.
Yeah, okay, that makes a lot of sense, and perhaps even I know PacketLight's also done well over here in the U.S. I think with smaller service providers that might not have, let's say, an AT&T sort of appetite, but maybe they might have multiple sites. I guess that might need something like this as well. I know that's
Correct.
kind of, yeah,
Exactly.
yeah. Um, the other question I have, I'm just throwing a few things out here, is, of course, there's a lot of demand in the market we see for 400G wavelengths. I mean, I assume these types of platforms could make, and one of the things that people talk to me about is like turn up time. I assume that these kinds of open devices could help with that. Make the turn up time for, let's say, if someone wanted a 400 gig wavelength from a small carrier or a large carrier, these kinds of devices can make that more efficient in terms of turn up time, or does that depend? I was curious about.
Take
Yeah.
over.
No,
Okay.
of course, this is one of the main motivations. So instead of going to each site and patching your new service or new wave and then patch between the maxes and so on, then by a few clicks you can enable the new service.
Oh, okay, great. And also, again, it has greater network management capabilities as well. It seems like
Sure.
that's also
So,
that's also another key thing there. I guess the other thing is, when we talk about getting to 800 gig, I mean, certainly, 400 gig wavelengths are the big news today, and 800 and 1.6T. And again, like I said, the ecosystem of these types of things that you both presented to me seems like that could be very helpful as a service provider, a hyperscaler, or like you said, some of these, uh, you know, entities that just have their own networks, I guess, could deploy these things. But I guess that all sort of helps them along that road, make it simpler to kind of get this to move along to the 800 gig and beyond kind of goal that we want. Yeah. Sorry, I'm not phrasing it the right way, but yeah.
so yes, of course, and I think that one of the option that Michal mentioned, when you have high port count of WSS, like 32 or even beyond that, people are just eliminate the need of the traditional passive max DMAX and connect the wave directly to the one of the port of those type of WSS, and this became like a tunable filters or tunable max DMAX. So even not in the very known tradition of using WSS, this became a very common component in the network those days.
All right, great. I also know that PacketLight's done well with like kind of aggregating traffic from other places like cable landing stations up to data centers. I mean, I assume that this type of platform could be good for those kinds of applications as well, right? Yeah.
Yes, of course, of course.
Okay.
So
Okay. Yeah. No.
anywhere that you need to let's say multiplex many waves, drop them across the line, or even in ring application, this is a must. In some point to point, it also became very common because of what I said before. It's used like a tunable filters, tunable max DMAX.
Okay. I'm going to keep going here for a few more minutes as they come in. Just to remind everybody, you can still continue to submit questions, and I'll throw some more out as I have here. But the next question is, what improvements in WSS performance would be beneficial to future network demands? Yeah, that's a good one.
So basically, today we have I don't know, 5 or 6 different baud rates that requiring different channel spacing. So once you put it in place, you will be ready for 1.6 tera or anything that will be in the future. Because once you can decide what is the channel width, you can do whatever you need in order to maintain your network.
Right. And I know I think in the presentation that was, talking about using different spectral bandwidth to kind of get up to 800 gig and being efficient. And yeah, no, I mean, there's some really great great things here. Okay, let's see. Yeah, and it sounds to me like from the beginning of the presentation too, there's different demands versus in different market, regions, like from Asia Pacific to Latin America to et cetera. But it seems to me like there's a lot of great flexibility, to use the term here, to kind of get this done and to kind of make things more efficient for people. Great. All right, I'm just going to remind everybody again, we still have some time for questions, but if I don't see any, maybe we'll go to, yeah. So let me see what else. And I also like the fact that maybe both of you could talk about this a little bit, that you can support the legacy and the next generation. And how important is that? I mean, if you're an existing carrier, and again, you're not going to have 800 gig everywhere or 400 gig, but maybe you might have a different mixture. And how important is that to your customer base? Because certainly everybody's at a different stage at this point, supporting the legacy and the next gen. Yeah, could address that a little bit.
It's very, very important, because you are not going to replace your network because you may need another channel of 400 gig or anything in the future. You want to maintain the same network, so you keep your capex low, okay? But and then you can add the new type of channels, and by that you also maintain very low OpEx. So altogether is the only solution that you have currently.
Okay. All right. Another question just came in. Like I said, we have time for a few more. This question is: do you expect high port count WSS to be attractive at high baud rates? For example, 60 plus ports. So he was asking. Yeah.
It's still a little bit in the horizon, because we cannot predict what will be the OSNR and how many hops it can pass in the future. Those very high rate services. But I believe that this will be part of the key features for those type of networks. Yes.
Okay, great. And another question here, more technical, I guess, is: are these meant to replace the passive DWDM muxes or work in conjunction with them? Yeah, that's a good question. Yeah.
So basically, there is no issue. For example, if you have high port count WSS, to take one port and tailor it 48 channel max DMAX 100 gig spacing, to take 50 gigahertz spacing max DMAX and tail it on another port, and take another max DMAX of 150 gigahertz spacing and tail it on another port. This is usable as well, and will give you maybe some flexibility, but then you will need again to lose the flexibility of the what Michal mentioned before as a colorless, because then you need to go and connect specific port to specific channel, and this is a little bit taking some of the advantages of those WSS. So I believe that as we will move in the future, we will see less and less passive and more those type of tunable filters or high port count. Yeah.
Okay. Another question that just came in. We'll take, like I said, maybe we'll take another one or two. What is the current OSNR threshold for 400 gig and 800 gig OTN? Are there any prospects that these will decrease significantly in the future?
So basically, I would say that there are two different view of that. Okay, so from view of regular pluggable or regular 800 gig, 400 gig, so you can see today something between 17 dB OSNR to 22 dB OSNR. However, if you are going to use submarine modems for 400 gig or 800 gig, then you will get much lower OSNR, but the baud rate will be much higher. So it's a trade-off.
Okay, great. Great. Okay. Well, I'm not seeing any more questions, and I mean, there's a lot more to explore. I think with PacketLight, and I would encourage everybody here that did attend the webinar to please follow up. We could, they certainly, want to continue the dialogue outside of the webinar as well. But as we end, I'd like to get, I could get the speakers just some final thoughts from both of you about this topic, which I think is kind of exciting and seems, as usual, the PacketLight's always got something interesting going on. But just get some final thoughts so we can close out the webinar, and then off we go. Thank you, for both of you.
Thank you.
So, well, I waited for this. I prepared. Well, Rina and Yael asked me to prepare. So first, we want to thank you for hosting these 3 series of webinars. So that's first. But as a closing sentence, if you're growing your network, all of you, if you have growing your number of services, if you know that you need already ROADMs, so this is the time to really send us an email and get in touch with one of our technical teams that will gladly sit and design the network for you.
Great. Awesome. Yeah, no, certainly I would encourage the audience here, if you have any other questions, please follow up, and feel free to go look at the other webinars that we had, which we did have a series of 3. And I want to thank again, my speakers today, Michal and PacketLight for supporting this great webinar series. And I look forward to hearing more about, what they're going to offer, especially in this exciting industry segment. So with that, I want to thank everybody for attending today, and I hope everybody has a great day. Thanks very much. Thank you.
Thank you. Thank you, everyone.
Thanks.